Okay, in class, we talked about granulation and the theory and technique of doing it with Gizmo and how to do that and explaining everything that goes into taking a sample and granulating it. But there are two problems with that. One, it's incredibly complicated and difficult to set up, and I know a lot of people were having trouble with the patch. And two, you can't really play it as a synth. So that's what we're going to look at right now. In order to do that, we need to go to the package manager and we need to install an external package that is called Percolate by Luc Dubois and Dan Truman. And this is just a great collection of objects for things like physical model synthesis. So, hey, you want an object called mandolin that sounds like a mandolin? We've got that. There's objects that sound like a sitar, that sound like a bowed string resonance model, some crazy wind stuff like brass, sax, clarinet. But the one that we're really interested in is an object that is called Munger, which is an audio effect, and it is a stereo granulator and pitch shifter. And this is a really cool object. It has just a ton of different controls that sound a little intimidating at first, but they're very easy. You've got the grain separation, which is the amount of time in milliseconds between grains. The grain rate variation, which is an offset variable rate change for the separation. The grain size in milliseconds and the variation size in milliseconds. The grain pitch factor and the pitch variation, and finally stereo spread. And these are just too much to use, so I'm going to copy those. Close that, close the file manager, and then I'm just going to paste those directly into my Max patch, along with creating the Munger object and giving it a argument of 1000 milliseconds for the max delay time. This does assume that it is stereo, so I'm just going to plug it in directly like that. And then I am going to connect things up. First and foremost, I need to have some sort of audio sample. So let's get one of those out. I'm going to go to the audio. I'm just going to grab this cello F2, lock my patch, make sure that audio is turned on and that it's looped. And we're going to send that into Munger. So that goes directly into there. Then I've got the grain separation, grain rate, grain size, followed by size variation, followed by pitch, pitch variation, and finally the stereo spread. And I'm going to add a load mess. I'm going to give it values that it defaults to in the help patch. So that is going to be 2, 0.5, 12, 500, 0, 1, and 1. And I'm just going to take that and go to unjoin. I'm going to give unjoin 7 because there are 7 values, and then I'm just going to connect those up one after the other. Okay, then I'll take that down so they're out of the way. A bit more. And let's turn this on, and you're not going to hear anything until I hit a key. Let's make sure that's set. And let's load mess. And now, here we go. Nothing so far, but if I hit a key and hold it down, we get some interesting stuff. And if I start changing the pitch factor, That's where I get the really interesting stuff. So with the pitch factor, that is what I'm going to use in order to transpose this and make this into a playable granular synthesis instrument. So how do I do that? Well, there's a couple things I need to do. Going back to Gizmo, what I'm going to do is I'm going to use our friend trans ratio, and I'm going to use that to send out a floating point number that is going to go to the pitch factor. So what is that floating point number going to be? Well, that's where it gets a little tricky. What I have to do is I have to assume the root key of the sample. So I'm just going to say, you know what, I think it's 60. I think it's middle C. We're just going to start with that. So I'm going to take that as the root. That is going to get subtracted from whatever's coming in, and that will create the trans ratio that will either go up or down depending on what I'm playing. So here's middle C. Octave above is 2. Another octave above that is 4. If I go down an octave, I get 0.5. I think we're good. But there's also another thing that needs to happen. I need to send Munger a couple of messages. Specifically, I need to send it a voices message. I'm going to tell it voices 8, so I've got 8-part polyphony. If we need it, I don't know that we do. And then the other thing that's really important, let me show you what happens when I start playing this. There's not a whole lot of difference, even though I'm going up by an octave. So what I'm going to do is I'm going to send it a message of tempered, which tells it that what's going to happen is that it is going to effectively assume that this is a tempered scale, and we're using a tempered set of pitch sieves to shift and retune the pitch. And in this case, the grain pitch variation will control the depth of how closely it tracks to that. So let's send it the tempered message, and let's try it again. Okay, so that absolutely works. Now, let's increase the amount of variation and try it. And by taking the grain pitch variation, which is effectively the depth of how closely it's tracking, below 1, I start to get interesting variations. I get more of that granular effect that you might be looking for. We can play with the grain size and the max grain size. And then let's also take the stereo spread halfway. And again, I can control that just by playing around with the pitch variation to control the depth. Which tends to force everything more into those tempered pitch sieves and make it track closer to actual pitch. So just a really, really cool, easy way to granulate a sample. If you're using something with the playlist, it does have to be looping, or you can use a live audio input just as well. But either way, this is a really cool, super easy way to get that granular effect. I use it for both effects and for granular synthesis type sounds.